Hello from Los Angeles. My name is Chase Morrison and I'm the Senior Consultant at Resource Planning Solutions. Welcome to our How to Parse Text Like a Pro free webinar. This video is actually part of a series of 10 videos produced by Resource Planning Solutions to help Excel users create performance management applications, mostly targeted for financial planning, reporting, and analysis. In this 1-hour video, we're going to show you how to parse text strings using Excel. The ability to effectively parse data in your applications is a really important skill for financial analysts. It's especially important given the fact that data generated by ERP systems and HRIS tools are not always in the format we need. So we'll walk you through the tools that we use to restructure data in our application. Feel free to download the example files and the PDF presentation. So let's get started. Before we get too far, we wanted to talk a little about our company. Resource Planning Solutions is a performance management consulting firm. Our services revolve around the delivery of and improvement to performance management. From 32,000 feet, think of performance management as all those tools and processes a company uses to define strategic goals and then measure and manage performance to those goals. Core aspects of performance management include financial planning, business modeling, consolidation, reporting, and the maintenance and monitoring of key performance indicators. Additionally, Resource Planning Solutions has a marketing partnership with Alight Planning. Their software product, also known as Alight, is a dedicated planning and analysis package that meets the needs of many mid-sized companies. Alight provides a number of capabilities that facilitate the implementation of numerous performance management processes that are typically in the too hard category when using Excel as a collaborative planning tool. A couple of those processes include the integration of actuals with the current plan. We all have been there. The plan was done 2 months ago, and now we have month 1 actuals in hand, and we now need to figure out the source of all the variances in our results. This problem is very seamless with Alight. Another more troublesome process is the creation of multiple scenarios. If you have ever had to create multiple scenarios using Excel and then compare them one to another, you know what I mean. It turns into a linking nightmare. Alight allows you to copy your current plan and create a second scenario based on that plan, and then you can go ahead and tweak that plan however you need to, and then you can compare the new scenario against the current plan, or you can create many other scenarios and compare them one against the other, and then start comparing actuals to the new scenario if that's really what you want to do. Alight makes it very easy to do all that, as well as the actual integration and multiple scenario capability. Alight supports multi-dimensional analysis. It has the ability to let you manage multiple users and manage the plan through various reporting and much more. In addition to Alight, we also design and implement custom Visual Basic applications. Many companies that have very specialized needs can see very significant gains with efficiency gains with customized Visual Basic applications. So that's about it for the shameless promotion part. So let's move on to the agenda. Well, here's the agenda for today's presentation. First off, a little counterintuitively, but we're going to start by defining what a text string is by talking about what a text string is not. So think of all the things that you can have in a cell on an Excel worksheet as a data object, and a string, or a text string, sorry, I may use string and text string interchangeably, but a string is just one of a number of data object types that you can have in a cell. After we go through that, we're going to take a look at some of the built-in functions in Excel that'll illustrate the different properties of various data objects. Once we go through that, then we're going to move into actually defining what a string is. And we're going to talk a little bit about how strings are constructed, which is really the basis for understanding how strings are manipulated. After that, then we're going to talk about what we term our core five. And basically our core five are the 5 functions that we use to do 95% of the text string manipulation that we typically run into. There are some other functions, but these core 5 are really the ones that you need to know. And once you need to know these core 5, then you're pretty well prepared to take on just about any text manipulation exercise you need to deploy. After that, we're going to then move on to a basic problem, which is one that we see over and over and over again, which is handling employee names and manipulating them into an order that we need them in, depending on how the data comes in versus how we have to handle them. Sometimes it's first name, last name, and we want last name, comma, first name, or vice versa. There's a number of different situations that we run into on name manipulation. So we'll show you how to do that. Then we're going to move on to a more complex example that requires us to use some nesting of our core 5 functions to actually extract data out of different parts of out of a resulting text string that comes out of a theoretical ERP system that we're going to go over. And then at the end, we're going to follow up with a numeric conversion example where we take numbers and we reformat them, and then we join them together with text strings to show you how you might be able to take 2 data objects and put them together to produce something that looks aesthetically appealing. Finally, at the end, we're going to go through some of the less commonly used, though still useful, string functions that you might be able to use. So let's move on to what a text string is not. Here we start the definition of what is a string. So there are a number of things that a text string is not, and here we just listed some of the things that you'll see on a spreadsheet that are not text strings. So the first one is a value, and we just want to be clear. You need to kind of watch out in that values are not text in the sense that they're text strings. Values are managed in Excel much differently than text strings are managed. So when you see a value that you can actually add something to, Excel is a very powerful program, and it tries to guess what you want to do or what you think you want to do. But sometimes it comes up with the wrong conclusion as to how you want to handle your data. So just be aware of the fact that sometimes values are text strings and sometimes are actual values, and you may need to handle them differently. So just very quickly, the other things are a formula. That is not a text string. Excel also has what are called Boolean or logical values. So sometimes you may see a true or a false in a cell, or generally that's the result of a if statement. Those are not text strings. And Excel has many internal constants, so sometimes you might see this percent or pound sign NA, which means not available. That's not a text string either. And then a blank text cell is also obviously not a text string. It's just kind of something of no value. So if you were to use is blank on that cell, it would tell you that with a cell address in the parentheses, if it returns true, then it's blank. So it's not anything. It's not a value. It's not a formula. It's just blank. So here you can summarize some of the different functions that are used to evaluate data objects in Excel. So Without getting too far into the sheet, you can just see there are a couple that we've already talked about. You can see the fourth one down. You can kind of see some discussion about the NA function, and then down in the lower left you can see the is blank. But here I want to switch over to actually using Excel to kind of show you how these work. So let's switch to Excel. So here we can kind of explore some of the properties that we're talking about relative to what is a text string and what isn't a text string. So up here in row 3, you can see the function that we're demonstrating is this is number. So there's a bunch of these is number functions, or I should say is functions, and is number is one of those functions. So here in column D, this is the value that we're going to take a look at. So if we use this is number function, and really column E is where all these functions are actually doing something. So we've set it up so that it is looking at cell D3, our 1, 2, 3, and it's saying is number that's located at D3, is that a number? And so obviously 1, 2, 3 is a number, so it evaluates to true. Over here in column F, this is where we have this is text function. So is text is another built-in function that whatever, as I mentioned, I believe earlier, whatever is within the parentheses. So here I have D3 in the parentheses, the 1, 2, 3. So when it looks at the 1, 2, 3, it's saying that is not a text string. So again, this is getting back to what I was telling you earlier, that values are not really text string. You may think that 1, 2, 3, hey, that's just a couple of digits, that should be a text string. It's not. And Excel will do some things to allow you to manipulate values like text strings, but as I said, sometimes you don't quite end up with the result that you want, so you need to have a little bit of caution. So here, obviously now, if I have ABC as my value that I'm going to give to my is number, that is not a text string, which is pretty obvious. And then over here, it evaluates to true. Having ABC is a text string, so that is now true. Another one is logical. So again, this is one of those Boolean data object types. So true, just true in a cell with no parentheses or anything, is going to evaluate to a logical value, and it's not text. So you can see again here is text is false. But here I put, as you can see, I put double quotes around the word true, and now that evaluates to false as far as being a logical value, but it is now a text value. So, putting just those double quotes around that value, which is one way to force a data object that is not it's not inherently a text type. You can force it to a text type using that. And then is reference. I mean, this is getting a little bit far afield, but is ref is evaluating whether a value in a cell is a reference to a valid cell. So cell A1 we know is a valid reference. So I can't really just map that in there. You have to put the value in there that you want it to check out. But this quintuple Z3 is not a valid cell reference. So as before, that was what we had in the cell, quintuple Z3. That's not a valid spreadsheet reference. But here, this is a little deceiving. I mean, cell references are not really strings, but these are really just text strings. Then is NA. So NA means not available. And then you can use this function here, is NA, as a way to test for whether a function is returning not available. And this gets a little more deeply into some other functions, but just suffice it to say that and is NA, a lot of these built-in functions that Excel will return, like a error or NA, these are not text strings either. But this one here, this is a text string, so that evaluated true and that's false. So you have to have the pound NA for Excel to think that is that's a actual NA. So you can see it up here with the parentheses around it. Then there's other ones down here, is error, is blank. These are other is functions, and you can go into Excel and look at all look at all the different is functions. By going up here, let me move this. It's a little easier to see. Usually these are the information types. So, is blank, is error, is even, is logical, is non-text. We didn't go over all these odd. So there's a number of is functions, and then you can just kind of click on them to see how they work. Okay, after that long discussion about what a text string is not, let's start talking about what a text string is, or at least the properties of a text string. So a text string needs to have a length of at least one character, and it cannot start with an apostrophe. And let me go to Excel to talk about what I mean relative to the apostrophe. As you recall, this data object is a value up here, 1, 2, 3, and as you can see down here, it is evaluating using the isNumber function as true. So here, if I want to force 1, 2, 3 to be a text string, I can put an apostrophe in front of it. So now, as you hopefully saw, this result here switched from true to false. See it again. There it is without the apostrophe, there it is with the apostrophe. So now it is no longer a value, it is true. So just a couple things to note here is that if I want to grab this now, you'll see that when I bring it over, there's no apostrophe. We know that there's apostrophe in this cell and that this is now a text string. So Excel is now treating this differently, because if it was a value into an unformatted cell, it would write justify it, and now it just left justified it. So it's treating 1, 2, 3 as text. And we'll get into this in a minute, but we know that if we look at this cell, that is, including the apostrophe, that is 4 characters. The 3, 2, 1, and apostrophe, that would be 4 characters. This function length here, that we're going to talk about in a little bit more detail in a minute, since that is a character string, I can use this length function. So intuitively, we would think since there's 4 characters there that it would return 4 characters, but it's only going to return 3 because it's ignoring the apostrophe that we use to force the value to be a text object. So in addition to the having a length of 1 or more characters and not starting with an apostrophe, here are some of the other properties of the string. It can start and end with spaces. So those are the spaces that you would hit using the space bar on your keyboard. Excel's isText function, if a data object evaluates a true, obviously you can, with the isText function, you can manipulate it as a string. Sometimes numbers can be manipulated as strings, but as I've stated earlier, you have to use caution. You'll probably have to use other functions, and we'll show you an example of that function towards the end of the webinar. But to get numbers formatted precisely the way you want them formatted will require probably a little bit of extra effort. Just about anything that is enclosed within double quotes is going to evaluate to be a text string. So numbers, just about anything is going to be a text string if it's enclosed in double quotes. Data that is enclosed in between double quotes in a formula is going to be treated as a text string. So we'll take a look at that later. Any data object that meets kind of the criteria above can be manipulated with our Core 5 Excel text functions. So continuing along with our properties of a string, all strings have a length of 1 or greater than 1. So if you look here, we have this common little phrase, the quick brown fox jumped over the lazy dog. That contains 44 characters. So if we were to use, remember that len or length function, and we had this phrase in a cell then we could use the length function. It would return 44 characters. And you have to remember blank characters or spaces, either leading or trailing, are just like any other space. So sometimes it's a little bit tricky because you can have blank spaces at the end of a text string, and it's a little difficult to see. But if we had 3 blank spaces at the end of our short little phrase, Excel would return 47 characters in the length function rather than 44 characters because our string is now 3 characters longer. So, in continuing on with our thought about how each character string has a length of 1 or more, without the spaces, our quick brown fox phrase is 44 characters long. And you can see in this little diagram here, this is probably an easier way to conceptualize it. So you would be thinking about each character in the string having an address along this 44 character line. So the L in lazy occupies the 37th space or ordinate in this 44 character string. So again, using this length function, if this phrase was at cell C1 and I said length C1 would return 44 because this character string is 41 characters. This find function is a function that, given that I am using only the first 2 parameters of this function, there is a third parameter that we'll talk about later, but basically what find does is it says find this character Z, the character Z in string, the string at C1, and so basically it just starts here at the first character and it starts looking down this string until it comes to the character Z, which would be here. Z is occupying, at least the first Z is occupying the 39th space along the string. So find Z on character string 31 returns this number 39, which tells you where in the character string Z, or what space it occupies in the character string. And you can also go looking for longer character strings. So the word lazy, basically what find would do is it would find an occurrence of these 3 characters in this order, L, A, Z, Y, in character string at C1. And you can see that L occupies the 37th character string. So it returns the position of the first character string. So if you want to peel this out of there, you would start at character 37. Now, one of the things that you can do with text strings is that you can join them together, but they can't really be added together precisely. So you don't use the plus sign here as we're showing here in this example. If you want to join these 2 strings together, you don't say the quick and then plus brown fox. What you do in the technical term is concatenate, but to concatenate 2 strings together, you use an ampersand. An ampersand is like a plus sign, if you can think of it that way. So if you wanted to join the quick and brown fox together to get the quick brown fox, you use the ampersand to join the 2 together. And you would want to notice that there's a blank space here in between the K and quick and this double quote, which gives me the space here. If I didn't have that space there, then the B in brown and the K in quick would be right next to each other. So you can either put the space before the B or after the K, but you're going to need a space in there. Otherwise, it's going to concatenate or join the 2 words together, and you're going to have something that you probably don't want. So if you want, you could do this. This is kind of showing you how you do this in a formula. But if in a cell you had the quick with a space at the end of the K, if it was in cell C1 and the brown fox was in cell D1, then the formula C1 and D1 would produce the same small little phrase. So basically, you can, with these different commands, you can start to extract and join text strings together to generate new valid text strings. So here we are finally at what we termed earlier as our core 5 text functions. And again, these are the text functions that are probably the most important for you to really know. So I would suggest that you go ahead and memorize these at some point or use them enough so that so that you have them memorized. They're pretty straightforward to use. The left function basically takes the text string that is referenced in the first parameter, and it just returns the number of characters from the left that you tell it to return. So if you have a text string at C1, left C1 comma 1 would return the leftmost character from that text string, and you can return as many characters are in the text string. Not that you'd want to, but theoretically that would be the limit. Right does the reverse of left. It starts from the right side of the text string and it pulls the rightmost character and then the second most rightmost character. So if you had right C1 comma 3 in a text string that was 10 characters long, it's going to return the 8th, ninth, and 10th characters. If you have a 3, C1 comma 3, it would return 8, 9, and 10, those 3 characters from the right side of the string. Mid is a bit more complicated, but I mean, you're going to be using mid a lot, and this is a function that we haven't talked about at all, but we're going to be going into it in depth here in a minute. But mid allows you to extract a defined number of characters out of a string. So again, text is where you would either have the text string or a reference to a cell, and then start is the starting point in the string that you want to begin the extraction, and then number of characters are just the number of characters that you want to extract out. So you could extract the same thing that we just extracted with our example earlier, only it would be mid. The text string is at C1. We wanted to start at the 8th character, so we would put in 8, comma 3. That would return the 8th, ninth, and 10th characters from that same string. But we're going to be using more complicated examples, because for the start and ending we're going to be using the find location to find the beginning and end from which we want Excel to be extracting characters. Find, we've already been over find a little bit. Here we're just showing you the third parameter in those square brackets. So you can change the starting location that you want seek to start. So remember earlier when we were finding strings within our quick brown fox phrase, we didn't tell it where to start from. So the default is to start from the character at character 1. If for various reasons you wanted it to start at another location, you could provide that other location, and we're going to show you how to do that in a minute as well. Length is the character or the function that returns the length of the character string. We've been over that quite a bit. And then ampersand is not really a function, but it is just a symbol that allows you to join two strings together. Okay, with all that background on how to use the core 5 and the properties of text strings, let's go into an example. So this is a pretty simple example. This is a pretty common one. So let's assume that we are getting a report or a flat file out of our HRIS system, and it is delivering the names to us all in column A when we import this file in, and all the names are joined together into one cell. Each name is one cell, and it's last name, comma, space, first name. So we term that comma, you can think of that as a delimiter in the string, and delimiters are a great thing because they allow us to actually parse strings. So we really do need these delimiters to enable us to do the parsing that we want to do, because if the whole thing was joined together, we wouldn't really be able to leverage Excel much. So you can use a delimiter, a comma as a delimiter. Sometimes you could even use a space as a delimiter, but you need to have something to grab a hold of so that you can figure out where to split the string, at least if you're trying to parse a name string. So here, assume that we have the last name, first name, and all the combinations. They're in column A, and we want to, the goal is to get the last name to column B and the first name to column C. So here is our example. It's very simplified. There you can see we've got about 5 names in column A, and we want to basically take and separate out the last name into column B and the first name into column C. And this was the way the information came out of our HRIS system. So this little trick is going to require us using the comma as our delimiter, and we're going to use the mid function and the find function to do the parsing. So step one is to extract out the last name. So in order to do this, we're going to use the mid function. So we're starting with the first name, Jones Fred, at cell A2. So here we say mid A2, we're referencing Jones Fred. We're telling the mid function to start at character 1. And then we're using this find function. We're saying find the comma in cell A2. And once you find that comma, then we need to back up one cell or one character to get the number of characters that we need to extract. So you can see here that that will return Jones. So the A2 is going to go down the string of Jones Fred, and it's going to find the comma at the, let's see, J is 1, O is 2, N is 3, E is 4, S is 5. So the comma is at the 6th space. So we want it to return 5 characters, because if it returned the 6th character, we would get the comma. So we would have Jones, comma, which is not what we want. We want to subtract 1 from the length that the find returned, taking it from 6 to 5, and then just return 5 characters starting at character 1, which will get us Jones. So just really quickly, doing the same thing in Excel, so we want to just get out Jones. So let me just show you what happens if we did not add in that -1 off the find. So there is A2, comma, and I want it to start at the first character, which will be the J in Jones, and I want it to do the find, and I want it to find our delimiter, which is the comma, and it's going to be in the A2 string. So this will return Jones with the comma. So there you can see we get the comma, which is not what we want. We want it without the comma, so I have to subtract 1 from the number of characters that the mid function is going to extract, and voila, there we get Jones, just the way we want it. So that's step 1. We got the last name, and then we can just copy this straight down to get all the last names out of the other text strings that we need. Okay, so now that we got the last name, now we need to extract out the first name, and it's basically the same process, maybe a little bit more complicated, but not much. So as you can see here, we're just using the same report. We got all the last names all parsed out just the way we want it to, and we're going to use the mid function again. Only this time we don't want it to start the extraction at character 1. We got to figure out where we want it to start. And again, we use the find function. We're going to use our delimiter because we're going to go searching for our delimiter. So remember, in our first example, when it comes along here and it looks at Jones, it's going to return 6 as being the character in the string where the comma is at. But there's a comma and a space and then the first letter of the first name. So what we want to do is we're going to want to, instead of subtracting 1 from the find, we're going to want to add 2, which is going to move us from character 6 past character 7 to character 8, where we want to start the actual extraction. So this find, comma, A2 plus 2 is going to return 8, and then we need to tell it how many characters we want it to extract out of the string. And here we're being a bit lazy. We're just going to give it the length of of the string A2 without being too complicated. This is more characters than we really need, but it's only going to return as many characters are left from 8 to the end of the string. So even though this is going to be more characters than we need, it's only going to give us what we want, which would be the 4 characters Fred. So again, this just explains exactly what it is we're doing. And once it goes through and it finds the comma and adds 2 to it, it's basically going to reduce down to this mid A2 8, 11, which is just really only going to bring Fred, the 4 characters, which is what we want. So let's take a look in Excel exactly how that's going to work. So again, here just showing you how to parse these first names out of here. So again, I'll show you here at first what happens if we don't add the 2 to the find. So there's our delimiter, the comma, A2. And then we just wanted to extract out the total length of A2, which is going to resolve to 11, but it'll only return 4. It's just going to return whatever's left from the find to the end of the string. And then you can see there we ended up with comma space Fred, which is not what we wanted. So now we just go back in and we add 2 to the starting position, and now we get Fred, and then we can go ahead and just copy this down, and voila, there we have it. We have parsed out the first names as well as the last names, which we did in the last step. So we're ready to move on. So with the last name and the first name all parsed out, the end result that we were hoping to get would be to restructure the last name, first name to first name, last name without a space, so that say theoretically we could use this in a mail merge application. So we got the names formatted like this out of our HRIS system. We parsed out the last name and the first name, and now we can restructure first name, last name with a space. And right here at D3, you can just kind of see the cell that or the formula that's required. So here we're taking C3, the first name, and we use an ampersand. Then we put a space, which is going to give us the space in between the last name and the first name, ampersand B3, and then that will concatenate the 2 strings together with a space in between the 2 so that we get the names just the way we want them, first name, last name, which is the way we want them in our mail merge application, which might be as a address, the start of an address with the name would be a possible use of this. So here's a more complicated example, and this is going to require us nesting some of our core 5 functions together. So let's take a look at this example. Let's assume that our ERP system generates an operations performance report that produces this long character string. So it starts with the part number as being the first section of data, and then there is a product hierarchy field, which is let's assume it's a family, and then it ends with the standard cost. So an example might look like this with the M367-0999978 as being the product number or part number, and then there's an asterisk as a delimiter, and then family 005, this is the product hierarchy or product family that this part number belongs to, and then the standard cost is the $455.5689. So we have these 3 pieces that we need to contend with, and the goal is that this long string starts out in column A, and we want to be able to parse out the part number into column B, the family into column C, and the standard cost into column D. Now, if the standard cost is always the same length, we could just use the write A28 to grab out the $458 $5 standard cost. But sometimes the standard cost is going to be less than $1. Sometimes it may be more than 1,000. So it has a. Let's assume that it's going to have a variable length. So we can't just do something as simple as taking this A2. So we need to nest the find function. So let's take a look at how we do that. Okay, so the first part is pretty simple. I mean, it's very similar to the way that we extracted the last name from the previous example, because we have a delimiter. Our delimiter is going to be the asterisk. So again, it's even at A2 is our first text string that we're going to parse. So we're going to use the mid function at A2. We're going to start at the first character. We need to find where the first asterisk is going to be, which is going to be right here after the 8 in the character string, if you remember what that looked like. And then we have to subtract 1, just like we did in the last name, to back up 1 character so that we don't get the asterisk, because that's not what we want. We don't want the asterisk returned with the part number, because it's not really part of the part number. So this should look pretty familiar. It's just like the last name example. Family is again pretty similar to the first name extraction in the previous example. So again, we're going to use the mid function, and again, what we want to do is we want to find where that first asterisk is, but there's no space that was embedded in our character string like in the last name first name example. So we just only need to move 1 plus 1 from where we find the asterisk to get to the first character, to the F in our product family name. Now, conveniently, all our families are 9 characters, so we can just extract 9 characters. Now, if we had to, if this was sometimes 8, sometimes 6, sometimes 7, we could figure that out. It would take a little bit more logic here at the third position to figure out how many characters. But for example, what we would do is we would find the second asterisk and kind of adjust the length accordingly. So then the standard cost is where we actually start to nest the find function. So if you'll remember way back, the find function has a third parameter that we haven't been using a whole lot, but the third parameter tells find where to start searching. By default, it starts searching at the first character, but if there's a third parameter, that tells it to start at the whatever number is in that third parameter, to start at that position to start the find. So here, what we want to do is you can think of it this way, that it's going to process this part of the of this mid function first in the find. So the find, we're doing a mid, or we're doing extraction here on A2, and we want to find an asterisk again in A2, but we want to adjust the start position, which is this underscore part. So this find is going to find the first asterisk, which is the asterisk that was in between the material number and the family. So it's going to find this. It's going to add 1 to it, or move it to the same position of the F here. It's going to move it 1 character past the first asterisk, which is where this F is, and then it's going to start searching from here forward, and it's going to find the second asterisk, which is in between the 5 in the family name and then the 4 in the standard cost. So that's what this part of the find will do. And this is nesting a find. So you can see here we have 2 finds together, and we're using a find to find the place to start, and then a find to find the second find finds the second asterisk. And then again, we're just being lazy, just telling it to extract out the length, which would theoretically extract more characters than we need, but it's just going to extract out to the end. So this formula here will extract out our standard cost for us. So let's take a look at how that works in Excel in a little more detail. So again, just very quickly, here's how we parse out the 3 pieces of our out of this export from our ERP system. So we use the mid function, and actually we're going to be at A5 is where the data is. And then we want to, for the part number, we can just start parsing at the first character, and then we want to find the delimiter in A5, and we want to subtract 1 from that to get the correct length, and there you go. There's the part number just the way we want it. So remember family. Now family was similar to the first name example in that we need to start at 1 character past our first delimiter. So we are parsing cell A5 and can't start at 1. We got to start there. We're going to go find our delimiter again in A5. And then we're going to add 1 character to it. And as I mentioned, the product families are always 9 characters or fixed length, so that makes it very easy. Then over here is the standard cost, and then this is where we actually have to do the nesting of the find function. So again, it's mid on A5, and we're going to want to find the second asterisk, right? So we want to find the second asterisk in A5, but now we're going to use this third parameter. We're going to tell the third parameter to find the first asterisk, because the second part over here is going to find the second asterisk if we start it 1 character past the first asterisk. So this is going to find the first one in A5. So this is going to resolve to the character where the first asterisk is, and then we add 1 so that it starts searching at the F. Okay, then that will produce the position of the second asterisk. And then we're just going to be lazy again, and we're going to just grab out all the remaining characters out of the string to the end, because this is the last part. And voila, there you go, except we kind of made a little bit of a boo-boo. We needed to start the first position at 1 past where we found the standard cost, because we're picking up that second asterisk, and there you go. And you can see it's left justified, so Excel is guessing that what we want is character data. So if I come over here and I say is text, this should resolve to true. So right now Excel thinks that $455 is a text value. So if we always knew that this was going to be that it was always going to be a value, and we just wanted to make sure that we got the right number, this value function will convert text to a value. So now if I do this, it's going to convert the standard cost into a value, and this true will change to a false because it will no longer be text. Okay. Okay, so just quickly closing up our little section on nesting functions. So this is just describing that last little step that we did where we enclosed the mid function that we use to extract out the standard cost at the end. So remember, we're dealing with a text string. That's the source data is a text string, and we need to convert that to a value because at some point we're going to be using that standard cost to do something. And this value function basically converts a text string, a string of numbers that are referenced as a text string, into a value. So this converts them back. So this is kind of doing the opposite of some of the stuff that we've been doing. So here's an interesting question for you. If our product family dimension, remember the middle part of our string that was coming out of our ERP system, if it was not 9 characters, if it could be 7 characters or 3 characters or 10 characters, what would you do? What is the changes that you would make to the to that second part to try and get the right number of characters extracted out of there? So let's take a look at that for a second. So here we have an example where the family is not 9 characters. So we just want to kind of look at, well, what's the changes that we would make to make this a little bit more robust. So currently it's set up for 9 characters, which you can see here in the example at row 6 and 7. I've changed the length, so here it's 8, and here it's what is it, 8, 9, 10, it's like 11 characters. So you can see I'm not getting the right answer here for the family, because here it's brought in the asterisk, which is not something that I want, and here it's missing the last 2 B's. So it's just pulling the 9 characters like the way that we originally set it up. So solving this is kind of a 2-part puzzle. So we know that this 9, this fixed length, is not working. So really what we want is we want this to go to the second asterisk. So that's part 1. That's not the final answer, but so let's do the same thing that we did in the standard cost. So we're going to have to find where the second asterisk is. So this is the first part of that. So we're going to change the starting position so that we move past the first asterisk here. So that's what this third parameter again is going to do for us, right? So if I do this, so now if I hit enter, it's not going to give me the right number, but I just want to show you what it's going to give me. It's going to give me the position of the second asterisk, which is in the number of characters. So in this string, that's going to be at let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So that second asterisk is at the 21st character, if I counted that correctly. So this is going to extract out starting at, the 1 character past the first asterisk is going to try and extract out 20 plus characters. So what's going to happen is it's going to give me the family, and it's also going to give me the standard cost, which is not what I want, but I just want you to see what happens here, and then I'll show you the solution. So there it is. So it gives me the family and the standard cost, just like I told you. It's extracting out too many characters. So the way that I want to fix this now is I want to subtract the starting position, right? So this is the starting position. By subtracting the starting position from the second ending position, then I'm going to get the right number of characters. So basically this is the starting position, and here I'm going to put a minus sign, and I'll put this in parentheses so it looks a little easier to see. But so now this whole part here is determining how many characters, and I know it's a little bit complicated, but you can take a look at this example and play around with it. But basically it's saying, hey, start at the second asterisk, and then subtract the length from this first one. So let's see, we might have to make a little adjustment here. We might end up with an asterisk that we don't want. Oh, there, it worked perfect. So there you can see that that allowed us. So now we have a variable family extraction tool. So now we can have this be whatever length it wants, and the finds using the delimiters will figure out how to get us exactly what we want out of the string. And it's doing everything else just the way we want it. So there's no other fixes that are required to implement that little simple solution. So one thing that we haven't really talked about is converting numbers back into text. So as I mentioned earlier, Excel will allow you to join a value with a text string, but it won't format it for you, and it won't carry over the formatting of the number, and I'll show you what I mean by that in just a minute. But let's assume that we have this one example here where we want to report what the cash receipts were for a day, and we have this value that's on our spreadsheet, this $404,592 and some change, and we want it to round to whole dollars and put in a dollar sign and give it to us as though it were in a little statement. So let's take a look at how we do that. And also we're going to want it to round to a whole number. So we'll show you what's going on there. Let's shift over to Excel. Okay, so here's our example where we want to join the value. Over here, this is a value. It's not a text string. Up here is our text string that we want to join with our value. And as we've been uh, mentioning all along, that Excel will join a value to our text string. Okay, but it basically it doesn't carry the formatting over to the value that it joins into our text string for us. So, even if I had formatted this number to have the formatting that I want, which would be a dollar sign with no decimals, it's still this still has the same formatting, or the same lack of formatting on it. So what I'm going to do is I'm going to come down here and I'm going to use the text function to format this number just the way it is formatted over here. So basically the text function um, converts values into text given the format that you provide to it, and these are just the standard Excel formatting characters. So if I do that, uh, this putting the 0 here, I'll always ensure that I have some value here. So if this were less than 1, it would have a 0 here. This is probably more relevant if we have decimal points. So there it is. So now it's formatted. So this number is not formatted, but it's formatting the number over here. So if you wanted decimals, you could add a couple decimals to get in the cents. And there you can see again it's rounding the cents for us automatically. It's rounding up through the text function. So you might want to at some point actually round this to be doubly sure, or if you have some kind of complex number format that you're using. So here if I said 0, now all my cents are going to go away because they're not going to make it to the format here because I'm getting rid of it in here in this round function. So I've got 0, 0 now because that round function got rid of the pennies. So that's how you convert a value into text and concatenate it onto a string with the desired formatting. So finally, here's a couple other helpful text functions that you might find a use for, and you can obviously go into Excel and look at the other text functions. But these are ones that certainly this proper gets occasional use, especially dealing with names that are coming out of HRIS systems, but proper attempts to put names into the proper capitalization. So, for example, if you had names coming out of your ERP or your HRIS system in all caps, it would convert the second letter on into lowercase and just maintain the capitalization on the first letter. Vice versa, if you had it all in lowercase, it would capitalize the first letter and leave the others in lowercase. So, this works pretty good for 90% of the names. If you have a lot of employees from Holland or elsewhere where they have some different capitalization rules, then it's not going to work quite as well. We didn't really get into left and right too much because we didn't really deal with having to extract fixed uh, segments of text either off the beginning or the end of character strings, but there is a lot of use for left and right, and so you might want to play around with those, but they're so straightforward that I wouldn't worry about it. Another helpful function is trim. So what trim does is it deletes leading and trailing spaces off of your text string. So on occasion, when you're extracting text or getting text from some other system, it may have blanks either on the end or at the beginning or both. And if you use trim, it's just going to get rid of all the trailing and leading blank spaces and just leave you with kind of the piece that's in between. So you can see here how running this example string here through trim kind of brought it right up to the T at the beginning and right to the S at the end. So that's what trim will do for you. So those are a couple little helpful tips that you can use. Well, that's about it for this webinar. Hope you were able to learn a little bit and get a better feeling for how to parse text using Excel. Uh, Feel free to contact us. Our contact information there is down at the bottom, or you can reach us at area code 818-436-0781. Again, we are Resource Planning Solutions. Send us your feedback. As a final part of this, we would really appreciate it if you take a very brief 5-question survey and help us get some feedback on how we're doing and help us understand how better to service our community. Thanks and have a great day. Bye bye.